Hello, this lesson is from Unit 612 on saturation and the use of Table G. So Table G is one of the reference tables that looks kind of the most intimidating, quite frankly. But however, once you get used to it and used to using it, it's really not so bad. What Table G is all about is telling us how much stuff we can dissolve into a certain amount of water before it hits that limit where anything that you add beyond that is just going to start settling down to the bottom and forming clumps. So if we take a look at Table G, what we're really going to see is 10 different graphs all kind of combined together to form one big mama huge graph of everything. So if you look closely on Table G, there are 10 lines on there. Each line represents a different substance. So just so that I can stay zoomed in, we're going to look at the substances that are down at the bottom of Table G. We got stuff like ammonium chloride. It has its own line, where potassium chloride has a different line, and sodium chloride has another different line. And you can tell that these different lines being there mean that those different substances have different limits to how much we can dissolve of them in water. And at this point, it's going to be really important to pay attention to the units on this graph. So down on our x-axis, we've got temperature in degrees Celsius. And what this is going to tell us is that the amount of stuff we can dissolve is dependent on the substances or the water's temperature. And you already knew that. It's easier to dissolve things in hot water than it is in cold water most of the time. On our x-axis, this is just sort of to standardize things. We've got reported solubility, and that's reported in grams. So let's take ammonium chloride, for example. At this point on the graph, we have dissolved 60 grams of ammonium chloride, and the temperature is about 65 degrees Celsius. The other important part about this y-axis is that it tells us exactly how much water we're dissolving into. And that will always be, for today, 100 grams of water. So that line that we were just sort of discussing tells us what the limit is for a particular substance at a particular temperature when you're dissolving it into 100 grams of water. So I want to make a couple notes about all the stuff that's going on here. And then we'll take a look at a couple more things about Table G tomorrow. But for now, let's just hit the basics. So I want to highlight ammonium chloride because we've been sort of looking at it already. This line right here is kind of like the limit line. At a different temperature, that line tells us exactly how much ammonium chloride we can dissolve into 100 grams of water. And if we have dissolved, let's say, we went with 65 degrees and 60 grams of ammonium chloride right there, we have what we call a saturated solution. So any point along that line we define as saturated, which really just means the max amount of solute has been dissolved. Anything that you add beyond that is just going to start settling down to the bottom in a stable way. So if we have, say, 90 grams of ammonium chloride and we try and dissolve it into 100 grams of water, unless the circumstances are very special, we're going to get a saturated solution and then some extra stuff down at the bottom. Now, let's say we only dissolved, 40 grams of ammonium chloride in water at 65 degrees Celsius. That would put us right there on the graph, which is well below the limit for that particular temperature. Anything falling below that line, we define as unsaturated. And any unsaturated solution is one where more solute can be dissolved. In fact, if we were here, we would be 20 grams away from saturation. We're at 40, the maximum limit for that temperature is 60, so we're 20 grams away from being saturated. Now, under very odd circumstances, there are times when you can break this saturated rule. You can kind of cheat the system and let's say dissolve 80 grams of ammonium chloride in water. And you would do that by heating the water up a lot and then not disturbing it and letting it cool down in a very special set of scenarios that only happen sometimes. But if you're able to 100% dissolve 80 grams of ammonium chloride in water, you've created what we call a supersaturated solution. And a supersaturated solution is one in which kind of too much has been able to dissolve. And 9 times out of 10 questions on Table G on the Regents exam are going to be about saturated solutions. You know, to say like at 50 degrees Celsius, how many grams of insert solute name here, potassium chloride, can you dissolve in 100 grams of water? But knowing these other two terms, unsaturated and supersaturated, are going to come in handy to describe solutions that are different from your regular saturated varieties. A lot of the stuff that we were making earlier in the unit when you made lemonade and that kind of thing, those were unsaturated solutions. Much more lemonade powder could have been added to our lemonade drink, but it would have tasted really nasty to make a completely saturated solution of lemonade. The one other note that I want to make about Table G today is that not all lines increase. All substances' solubility depends on temperature, and 7 out of the 10 of them show this increasing trend that with increasing temperature comes increasing solubility. But if you notice, SO2, NH3, and HCl are 3 substances whose lines all decrease, which is to say that when temperature increases, their solubility limits also decrease. And what's noteworthy about those 3 substances is that at STP, they are all gases. So for gases, as temperature increases, solubility decreases. Which is interesting, but it's something that you've experienced before. If you have a can or a bottle of soda, it's much easier to keep it nice and bubbly with all that dissolved carbon dioxide if you keep it in the fridge than if you lay it out on a hot summer day or even just have it out at room temperature, because that increasing temperature gives those gas particles more energy, which allows them to escape out of the solution and kind of undissolve. What we can do to try and trick the gas particles into staying in is by increasing the pressure. So gases only are sensitive to pressure when it comes to solubility. And if you increase the pressure, just imagine like that tight cap on a bottle of soda. As soon as you release the cap, you hear the tss that shows that the gas is undissolving. Increasing pressure will actually allow us to force more gas molecules down into a liquid. This is not true for solids. They're not affected at all by pressure. And we see on the Table G graph that their solubility actually increases with increasing temperature. So there's that difference in patterns there. Just take note, majority of the substances on here are electrolytes with the exceptions of the 3 circled gas substances. But mainly what I want you walking away from 612 with is this idea that all the lines on this messy graph represent saturation limits for different solutions, and you should be able to tell me what the saturation limit is for different substances at different temperatures.